So we've learned the basic aspects of addressing. Now, in this lesson, we're going to write a simple program to run a three-phase electric motor. Okay, so if we want to turn on a three-phase motor, we need to connect a three-phase power supply. With the motor connected, it will run continually, but what we really want is the ability to turn the motor on and off whenever required, which means that we need to introduce a switch so that we can turn the power on and off. The most commonly used switch in the industry for this purpose is a contactor. A contactor has two main parts, a coil and some open or closed contacts. It works by connecting these three phases to its open contacts and then applying a voltage to its coil. The applied voltage creates an electromagnetic effect which closes the contacts, resulting in the three-phase power being delivered to the motor, turning it on. So by using the contactor, we can connect and cut the electricity supply, which in turn results in the motor being switched on and off. We know that we need to apply a voltage to the contactor's coil, so the coil is the component that should receive our command. Now, in your experience, what is the most suitable equipment to use in order to command the coil? That's right, a PLC. We can install the PLC that we configured in previous lessons, connecting the contactor's coil to the PLC's output. This will allow the PLC to energize the coil by sending an electrical signal to it. But how does the PLC know exactly when to send the signal? Well, we can connect a momentary start push button to the PLC's input. And here, when we hit the push button, it sends a signal to the PLC's input module. This tells the PLC that we have sent a command. The PLC's language is known as signal language. It can't understand English, Spanish, or any other language. But the push button gives us the ability to talk to the PLC in a language it understands. So we know that the PLC understands whenever we've sent a command. But how does it know exactly what to do after receiving the command? In other words, the PLC is saying, okay, I know you're telling me something, but what exactly are you telling me? What do you want me to do? So, we should tell the PLC, whenever you receive this signal, I want you to send a signal to the contactor's coil. So how do we say this to the PLC? That's right, with programming. So now, instead of signal language, we will use a programming language to talk to the PLC. To write the program, we need to enter the Somatic Manager environment. As we learned earlier, we write our programs in the OB1 folder. So first, open the Blocks folder and then double-click OB1 to enter the programming environment. This section is where we should write our program, in the first network on this line. Okay, we're using a push-button switch connected to the input, so to get started with the program, we can select an open contact from the BitLogic folder here and import it to the programming environment. Another way of doing this is to import the open contact through the toolbar. Now, we need to enter an address for this contact. First, check which input of the digital input module the push-button switch is physically connected to. Here, we can see that the switch is connected to the first input of the digital input. So what is the address of this input? To work that out, we need to go back to the hardware. Here we can see in the I address section that the address of this module starts with the byte number 0 of PII and goes to byte number 3 as the default. So considering this PII memory space, the addresses of these first 4 bytes will be related to our DI module. So the input addresses range from I00 to I37. This is 4 bytes, or 32 bits, or 32 inputs. So how are these addresses displayed on the module? The address of the first input is I00, which, like all the addresses, is directly related to the PII. So the second address is I01, and this sequence continues logically up to the final input, which is I37. So as you can see here, the address of the first input where we've connected the start push button is I00. So now we go back to the programming environment and enter I00 here. Then hit enter twice so that the address will be assigned to the contact. Okay, so what do we need to enter for the output? Well, we've connected the contactor coil to the digital output module, so we can use a coil in the program too. Click on the program line again, select it, and then here in the BitLogic folder, we can click on this coil icon to add it to the program line. Now, what address do we enter for the coil? If we go back to the hardware environment, we can see in the Q address section that the addresses for the DO module range from byte number 4 to byte number 5 in the PIQ.